Welcome back. So we are basically analyzing a signal जिसका description, it's a square wave, it's a periodic square wave, and we need its Fourier series representation. So general form of is this, and we need to compute the coefficients from the analysis equation. The coefficients के लिए we will be using a of k is equivalent to 1 by t over the time period t x of t e raised power minus j k omega naught t. Now you are here, you have to be a bit careful. यहाँ पे although the time period, the fundamental time period has capital T, but the time period is extending from minus t by 2 to t by 2, not from 0 to t. तो जो हमने general analysis किया था, it was over the time period t, which is still the same, but we had assumed that the time period is extending from 0 to t. अब यहाँ पे it is changing, तो आपका जो integral होगा इसके limits they will change. ठीक है? Okay, so let's start computing the coefficients. Obviously we'll be starting with a0. It will be 1 by t. The time period is still t, but the time period will extend from minus t by 2 to capital T by 2. फिर आपका सिग्नल आ गया x of t. अब क्योंकि a 0 है तो ये वाला कंपोनेंट तो 1 ही होगा, so let's not write it. ठीक है? Then again I will modify it because minus t by 2 to t minus t1, then from t1 to t by 2 it is actually 0, so it is only defined from minus t1, not actually defined, it has a value 1 in this range, so it will be 1 dt, which will be 1 by t minus t1 to capital T1. इसका तो t आएगा, then when we will no, it will be something like this. It will be t between the limits, this thing. So when you will use a value, so it will be 2t1 by t. Okay, so this will be a0. So then we have to compute the next values, that is when k is not equivalent to 0. Okay, that is ak. So this case it will be 1 by t again from minus t by 2 to capital T by 2 x of t e raised power minus j k omega naught t dt. Okay, but again I will change these limits because it has a value of 1 from minus t1 to capital T1, तो इस केस में xt1 है, तो जो हमारा इंटीग्रल रहेगा it will be this. Right? It's a simple exponential, you can easily evaluate it. So this will have a value of minus minus 1 by जो इसका exponent, that will be outside j k omega naught t, and limits will have to be for this part we'll have to proceed to limits like this. And again you can do a bit of manipulation to express it in a better way. So ये बाहर रहेगा, here it will be e raised power minus j omega naught k t1 minus e raised power, okay, minus will go, j omega naught k t1. Fine. उसके बाद you can express it in what I will do is multiply by 2, बाहर रहेगा k omega naught t, अंदर मैं ले जाऊंगा e raised power j omega. I'm skipping some steps, but I'm sure कि आप ये you will be able to understand it. Yeah, you can do yourself the missing steps, and it will be 2 and the j. Okay, then from the Euler's relation it is 2k omega naught t, and this will be sine of k omega naught t1. So it will be sine k omega naught t1 और ये जो हमारा कंपोनेंट है 2, तो ओमेगा नॉट की जगह या दिस आई थिंक वी हैव ओके थोड़ा सा यहाँ पे दिस इज़ नॉट टी, दिस इज़ कैपिटल टी, राइट। लेट मी जस्ट चेक, हाँ कैपिटल टी है तो ये ऐसे आएगा, ठीक है। सो के ओमेगा नॉट टी की जगह विल सब्स्टिट्यूट 2 पाई बाय ओमेगा नॉट, सो दिस एंड दिस विल गो, 2 and 2 विल गो, तो हमारे पास जो रहेगा इट विल बी साइन के ओमेगा नॉट T1 बाय के पाई, सो दिस विल बी माई ए ऑफ के, ठीक है। नाउ आई एम मेकिंग एन assumption here, so let's assume so that थोड़ा और सिंप्लीफाई हो जाए कि you see you have the period t, ये आपका एक पीरियड है, although he is not expressing any relationship between t1 and t/2, but let me assume that t1, that is this, is equivalent to t/4, okay. Let us put this additional condition. What I mean by this is I am assuming कि ये जो मेरा square wave है, I am assuming that the square wave is unity for half the period and 0 for half the period, ठीक है। अब अगर आप देखेंगे from minus t1 to plus t1 it is having a value 1, ठीक है। So it's having a value of 1 for this particular, so minus t1 to 2 हो गया, 2t1 के लिए it is having a value of 1, fine. Then from here to here and here to here it's having a value of 0. What I am assuming here that this plus this जो ये टाइम पीरियड आ रहा है इट इज़ एक्चुअली इक्वलेंट टू दिस टाइम पीरियड, ठीक है। वही मैंने यहाँ पे एक्सप्रेस किया, t1 इज़ इक्वलेंट टू t/4, फाइन। दिस इज़ बेसिकली द रिप्रेजेंटेशन फॉर दिस, दैट आई एम एज्यूमिंग कि जो मेरा ये स्क्वायर वेव है इसका जो एक पीरियड है, प्रॉब्लम यह है कि ये थोड़ा डिस्ट्रीब्यूट है, द 0 पार्ट्स आर डिस्ट्रीब्यूटेड ऑन ईदर साइड ऑफ 1 पार्ट, फाइन। बट आई एम मेकिंग दिस assumption कि जो मेरा t1 है that is this part, it is actually equivalent to t/4, right? So we sometimes express it as a duty cycle. It has a duty cycle of 50%, which means जितने टाइम के लिए इसका वैल्यू 0 है उतने टाइम के लिए इसका वैल्यू 1 है, right? This is an additional condition just to further simplify जो हमारा कोएफिशिएंट का एक्सप्रेशन था, okay? So t1 and t is related by this, right? क्योंकि जो आपका ओवरऑल पार्ट है ना, ओवरऑल टाइम पीरियड टी है, सो आई एम ब्रेकिंग दिस स्केल इनटू 4 पार्ट्स, एक पार्ट, दूसरा पार्ट, तीसरा पार्ट, चौथा पार्ट, ठीक है। तो एक पार्ट का लेंथ है t/4, ऑब्वियसली इक्वल पार्ट्स में जब डिस्ट्रीब्यूट करेंगे, तो दिस इज़ बेसिकली द लेंथ ऑफ दिस पार्ट, वही मैं यहाँ पे एक्सप्रेस कर रहा हूँ। तो विद दिस एजम्पशन कि मेरा जो सिग्नल जो स्क्वायर वेव है जिस टाइम के लिए इसका वैल्यू 1 है एग्जैक्टली उतने ही टाइम के लिए उसका 0 है, आई कम अप विद द रिलेशन दैट t1 इज इक्वल टू t/4, तो आई कैन सब्स्टिट्यूट दैट हेयर। तो now we have t is equal to 2 pi/omega naught, अब t की जगह आई विल पुट 4t1 is equivalent to 2 pi/omega naught, which will further imply that omega naught t1 is equivalent to pi/2। ये जब नीचे लेंगे तो वो अब मैं यहाँ पे सब्स्टिट्यूट करूँगा, ठीक है। that a of k will be sine k omega naught t1 की जगह pi by 2, then I will have k pi here. ठीक है, चलिए. So up to this point we have found the values. a0 हमने पहले ही calculate करके रखा था, that was I think 2t1 by t. हाँ, 2t1 by t. Now we have come up, इसमें भी हम you can use this t1 is equal to t by 4. तो जब आप ये सब्स्टिट्यूट करेंगे इसका जो फॉर्म आएगा t1 by 4 t1 it which means it will be 1 by 2. ठीक है, फिर हमारा a के हमने अभी कैलकुलेट किया, it is sin pi k by 2 by k pi. Now you can give different values. For example, I want to compute a of 1. It will be sine of pi by 2 by pi. Sine pi by 2 is 1, so it will be 1 by pi. ठीक है, आपका जो साइन सिग्नल होता है, yeah, you can just compute other coefficients. So this will be sine pi by 2 pi, which will be 0. फिर अगर आप a3 compute करेंगे, it will be sine 3 pi by 2 by 3 pi, that will be minus 1 by 3 pi. Then a4 sine of 2 pi by 4 pi, which will again be 0. ठीक है, similarly you can also take some negative values. If you want to compute a minus 1, it will be sine of minus pi by 2 minus pi. Fine, that will be again sine of minus 1 by pi by 2 is minus 1, then minus and minus will go, so it will be 1 by pi, which by the way is the same as a1. Then you can proceed with the analysis. A of minus 2, it will again be sine of minus pi by I think minus 2 pi, which will again be 0, which is equivalent to a2. इसी तरह अगर आप a minus 3 देखेंगे, that will again be sine of minus 3 pi by 2 minus 3 pi. Again that will be minus 1 by 3 pi, which again is a of 3. तो symmetric coefficients आ रहे हैं. A of minus 4 will again be 0. A of minus 5 will again be some equivalent to A of 5 will be sine of 5 pi by 2, then 5 pi, which is 1 by 5 pi. इसी तरह you can come up with a lot of harmonics. But जितना जितना हम higher value of k देंगे both on the negative and the positive side, उतने ज़्यादा आपके पास हार्मोनिक्स आएंगे. So if I have to compile up the series, तो x of t जो मेरा था, the Fourier representation of this signal a k e raised power j k omega naught t, so it will be dot 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 a minus 5 e raised power minus j this plus a minus 3 e raised power minus j3 omega naught t minus 1 e raised power minus j omega naught t. Then I will have a constant term a0. Then I will have the positive coefficients plus a, क्योंकि even coefficients में इसलिए यूज़ नहीं कर रहा हूँ कि because their values are 0, right? So I'm not using them here. a3 e raised power j3 omega naught t, then there will be a5 e raised power j. इसी तरह आप जितना भी कंटिन्यू करना चाहिए it will have. Then you can just rearrange. पहले हम constant term लिखेंगे जो हमारा क्या वैल्यू आया था 1 by 2. Then क्योंकि a minus 1 was the same as a1, so I can क्या था 1 by pi बाहर निकाल सकते हैं. e raised power j omega naught t plus e raised power minus j omega naught t. Similarly minus 1 by 3 pi e raised power j3 omega naught t plus e raised power minus j3 omega naught t, and likewise. Okay? Then you can again use that Euler's relationship, that will be 1 by pi 2 cos omega naught t minus 1 by 3 pi 2 cos 3 omega naught t, and likewise plus 1 by 5 pi 2 cos 5 omega naught t dot dot dot. Okay, so this is the constant DC term. This is the first harmonic, second harmonic, third harmonic, and likewise if you continue you can have higher harmonics, right? So this is the Fourier series representation. यहाँ पे हमने पहले analysis equation use किया to find the coefficient values. Then we use those coefficients in our synthesis equation to have an expression for x of t in terms of these harmonics. Okay? So this is the Fourier series representation. Right? All of this is mathematical, but you need to understand the physical, some physical relevances that these equations are giving us. Again, मैं वही बात कहूँगा, time analysis में we expressed our signal x of t as a sum of as a linear sum of shifted impulses, but यहाँ पे for frequency analysis through Fourier series we are expressing our x of t as a linear combination of complex exponentials which are harmonically, please remember this, these are harmonically related. जो मैंने पहला वीडियो इसमें दिया था Fourier series में, there on I try to explain what I mean by harmonic relations. आपका जो normal exponential है e raised power j omega t and the exponential wherein the factor of k was involved, they are harmonically related, means उनका time period same है and fundamental period and fundamental frequency of those individual exponentials, they are also related through the factor k. Okay? So we'll stop here. In the subsequent videos we will be discussing some of the properties of the continuous time Fourier series. We'll be discussing what about the linearity of the Fourier series and other time shift. जो भी हमने time domain में properties पढ़ी थी, we will see what will happen to those properties in the Fourier domain when we apply the Fourier series.